Today's Army moves and works and fights on tracks and wheels. Never before have our weapons been so mobile. Never before has such a variety of support facilities taken to the road. All vehicles must be ready to go anytime to any place. They have to travel on good roads, bad roads, and even on no roads at all. Across fields and rice paddies, mud and water must not stop them. Cold weather and other problems presented by Arctic terrain must not stop them. Everywhere the Army goes, go thousands of drums of lubricants for bearings, gears, and all kinds of moving parts. The heart of a vehicle is its engine, but the life of the engine is dependent on a good operator. Without proper lubrication, precisely fitted parts cannot deliver full power. Indeed, without proper lubrication, the engine will fail. For want of proper lubrication, many a vehicle has been lost. Unlike other moving units, the engine is designed to lubricate itself. Except for regular servicing, it requires little help from the vehicle crew, but it does require understanding of the principles of lubrication. The lubrication of automotive engines varies slightly with each new design, but generally there are three systems. These systems are the combination splash and force feed, the force feed, and the full force feed. Various points of the engine are pressure or force lubricated, the same in each of these systems. The oil pump picks up oil from the oil pan and delivers it under pressure to the main oil gallery. From the main oil gallery, the oil is directed through passages to the camshaft bearing and to the main bearings on the crankshaft. The oil circulates constantly around these bearings and drips back into the crankcase. In overhead valve engine, the oil is forced through passages from the main oil gallery into the rocker arm shaft, through holes in the rocker arm shaft and around the rocker arms. It drips around the valve springs and drains back to the crankcase through the push rod openings. The major difference in each lubricating system is the method of lubricating the cylinder wall, piston, piston pin, and connecting rod bearings. The combination splash and force feed system, an older system no longer much used, has dippers that are attached to the connecting rod bearing caps. A drilled passage in the connecting rod cap directs the oil to the connecting rod bearings. The dippers pass through the troughs in the crankcase. When the oil pump operates, the dippers and troughs are filled with oil directed by spray nozzles. As the engine runs, the dippers pick up oil from the oil trough and throw the oil into the cylinder. The cylinder walls, the pistons, and the piston pins are lubricated by the oil that is thrown into the cylinder. The connecting rod bearing is lubricated by oil forced through the drilled passage in the connecting rod cap. In the force feed lubrication system, when the engine is started, the oil is forced under pressure to the camshaft bearings, the crankshaft bearings, and the overhead valve mechanism, as in the combination splash and force feed system. But in the force feed system, there are drilled passages in the crankshaft, from the main bearing to the connecting rod throws. After the oil circulates around the main bearings and the connecting rod bearings, it is forced through spray holes or nozzles into the cylinder. The oil sprayed into the cylinder lubricates the cylinder walls, pistons, and piston pins. In the full force lubrication system, when the pump operates, the oil is forced under pressure through the main oil gallery, through passages to the camshaft bearings, and from there to the main bearings. The oil circulates around the main bearings and is directed through drilled passages in the crankshaft to the connecting rod bearings. After lubricating the connecting rod bearings, the oil is directed through a passage to the piston pin. This ensures lubrication of the pin and cylinder wall. Each of these systems is designed to supply the right amount of oil every place it is needed to keep moving parts working at top efficiency. But it doesn't work out that way when Freddie Follow-Up is on the job. Not when he doles out the oil as if he were weaning a baby. Or worse yet, when he slops in more oil than the engine can handle. Any old oil, regardless of operating conditions. Naturally, Freddie has a lot of engine trouble. It's too bad that a misused engine can't hit back. To many persons, lubricating means simply oiling or greasing to keep moving parts working together smoothly. That's true enough, applied to lubricating many bearing surfaces. But engine lubrication has more than one function. It has 4 functions. Its primary function is to prevent metal-to-metal contact. Second, it assists in carrying away heat from the engine. Third, it seals the spaces between the pistons and cylinder walls, preventing blow-by. And fourth, it cleans the engine parts as it lubricates. The greatest enemy of an engine is metal-to-metal contact. It causes friction, generates heat, starts rapid wear, and lowers efficiency of operation. Let's demonstrate what metal-to-metal contact does to moving parts. Try pushing a block of smooth, dry metal across another smooth, dry metal surface. It doesn't slide easily because, as this magnified view shows, the two smooth surfaces aren't really smooth at all. Tiny ragged edges interlock, resist movement. If moved very rapidly, heat would be generated and the surface would be destroyed. This friction, as we can see, causes resistance and wastes energy, whether it is manpower or engine power. Now let's put a film of oil between these metal surfaces. What a difference! The block almost moves by itself. Gone is the friction. Gone is the resistance. With the film of oil separating the surfaces, wear and tear is reduced to a minimum. Think what that means with a snugly fitting piston moving in a cylinder at operating speed. The oil creates a film between the curved surfaces of the piston and cylinder. What is an oil film? To the eye, it appears to be just a simple sliding surface. Actually, it's rather complex. To understand what it is, imagine the film made up of layers of tiny globules of oil. The layers next to the metal bearing surfaces will stick to these surfaces. They will be carried along as if they were part of the metal. While the outer layers are frozen to the moving surfaces, the in-between layers of globules can slide on each other and on the layers frozen to the metal, as if they were tiny ball bearings. Let this diagram represent the proper thickness of oil film to give full lubrication. We show it as 5 layers, just for the sake of explanation. When we reduce the oil film to less than 5 layers, lubrication is partial or boundary. That is, friction has not been reduced to a minimum or safe point. If there are less than 3 layers, there is insufficient lubrication between the bearing parts. Metal-to-metal contact may result, and the remaining 2 layers, which stick to the metal so that they also act as solids, tend to score the moving surfaces, causing excessive friction. Bearing surfaces are rapidly destroyed by metal-to-metal contact of moving parts. Imagine these pistons sliding up and down inside the cylinders at great speeds and without proper lubrication. When insufficient lubrication causes a piston assembly to freeze in a cylinder, this is what happens. Something had to go, in this case a connecting rod. Here are more examples of bearing surfaces worn, scored, and ruined by faulty lubrication. And in addition, there's the cost of thousands of hours of labor, the vehicles taken out of service, and sometimes the complete destruction of engines. And so, the primary function of engine lubrication is to prevent metal-to-metal contact, thus reducing friction, wear, and greatly improving operating efficiency. The second function is to assist in carrying away heat from the engine. In an an internal combustion engine, the speed of movement of engine parts and the rapid burning of fuel generates heat, so that the engine parts become extremely hot. Engine heat is carried away by several means. In wheeled vehicles, the hot oil is returned directly to the crankcase. As the vehicle moves, the air flowing past the crankcase also assists in cooling the oil. In most air-cooled engines, the hot oil passes through oil coolers usually mounted on each side of the engine. And as we have seen, the engine itself has a lubrication system which not only circulates the oil, but also draws heat away from the engine. Thus, lubrication shares in the task of cooling the engine. The third function of engine lubrication is to seal the spaces between the pistons and the cylinder walls, thus preventing blow-by. Blow-by is the escape of combustion gases between a piston and cylinder wall and the power stroke. Though piston and cylinder are made to fit within a tolerance of a few thousandths of an inch, there must be some space between the cylinder wall and the piston to allow the piston to move. This space must be sealed to prevent blow-by and to apply the full force of the burning fuel against the piston. The piston rings alone can't do this sealing job. The lubricating oil must seal the space between the piston rings and the cylinder walls. If the oil film is inadequate, the gases cannot be completely sealed in the combustion chamber. Let's freeze the action and catch blow-by in the act of stealing power. Even more, it's contributing to friction and wear. As the unburned fuel and exhaust gases blow past the piston, they wash the oil film from the piston and cylinder wall. When the unburned fuel and exhaust gases reach the crankcase, they contaminate and dilute the oil. The diluted oil is squeezed from between the bearing surfaces and metal-to-metal contact results. The consequences can be disastrous. Thus, the third function of engine lubrication is to seal power in the cylinders by preventing blow-by. The fourth function is to clean the engine parts as they are lubricated. Mud particles, metal fragments from engine parts, and other foreign matter contaminate the oil, and if allowed to remain in the engine, will shorten its useful life. The foreign matter may also clog oil lines and reduce engine efficiency. However, the lubricating oil acts as a cleaning agent, carrying these particles away from the engine. The air cleaner helps reduce the amount of contamination by filtering the air as it enters the engine. To make the most of this protection, be sure to service the air cleaner at proper intervals. These will vary with operating conditions. Moisture may condense in the crankcase, especially during cold or wet weather. This is another thing which will destroy the lubricating properties of engine oil. The contamination may form acid, which will damage engine parts. The crankcase ventilation system aids in eliminating some of the condensation from the crankcase. Air circulates through the crankcase and carries the contaminated vapors into the combustion chambers where they are burned, or in some systems they are allowed to be discharged to the atmosphere. The lubricant passes through an oil filter. Here, some of the contamination is removed so that the clean oil returns to the engine. This is a constant cycle. In time, depending on operating conditions, these filters will become clogged if not changed regularly. But if they are changed at specified intervals, the oil will be kept clean and maintain its effectiveness. All Army lubricating oils contain a cleaning agent which supplements the cleaning action of the oil filter. Impurities small enough to pass through the filter are kept in suspension in the oil and not allowed to settle on engine parts. These small impurities are removed with the oil when it is drained. In draining, be sure to let all the oil possible run out before replacing the plug. And so, the fourth and final function of lubricating of the engine is to serve as a cleaning agent, to remove contamination, and thus prevent deterioration of the engine parts. To satisfy the operating requirement, you must use the right oil and the right amount. Insufficient and improper lubrication results in friction and wear. The passages will not fill as they should. Pressure cannot be maintained, and the camshaft bearings, crankshaft bearings, and piston pins will not be properly lubricated. To be sure that all parts of the engine will be properly lubricated, keep the oil in the crankcase at the specified level given in the lubrication order for each vehicle. It is very important to use the grade of oil specified for the particular operating condition. To use any old grade invites engine failures and breakdowns. The thickness of an oil will change with temperature. Maybe you've heard of the old saying, as slow as cold molasses. Well, this oil is so cold it would not circulate fast enough to provide safe lubrication in an engine. Now we'll heat some of this cold oil and see what happens. That's the heated oil on the right. It has become much thinner so that it flows faster and spreads more. So naturally, in cold weather, a light or thin oil or lubricant must be used to get fast circulation in all parts of the engine, particularly when starting. In hot weather operations, use a thicker oil. Always select the lubricant according to the weather, not by the time of year. The most commonly used types of engine lubricants are OE10, OE30, OE50, and OES. The lubrication order for each vehicle will guide you in selecting the proper grade. It is not necessary to change the oil just because it looks a little dirty. The cleaning agent in the oil keeps the impurities in suspension, so change the oil according to mileage, hours, or operating conditions, as indicated in the lubrication order. Be sure to change the oil filter regularly, as specified. With these simple maintenance operations performed at the proper times, the engine lubrication system should work at top efficiency. If the system should fail, even with sufficient oil in the crankcase, the engine will soon be useless if allowed to keep on running. Look at your gauge from time to time and make sure it comes up to the proper pressure. Here are some points to remember. There are three systems of engine lubrication: combination, splash, and four-speed, and full four-speed. Lubrication of the engine has four functions: to prevent metal-to-metal contact, which creates friction, wear, and inefficient operation; to assist in carrying away heat from the engine; to seal the spaces between pistons and cylinders, preventing blow-by; and to clean the engine parts as it lubricates. For efficient operation, use the grade of oil specified for the operating condition. Change the oil and the oil filter as recommended in the lubrication order. The vehicles that serve the Army in continental United States and other lands are many and varied. They must operate in water, mud, and storms. They must operate in bitter cold and tropical heat, on bad roads and no roads. To keep a safe film of oil between snugly fitting engine parts that are moving together at great speeds is a simple job of maintenance, but a vital one. You cannot afford an engine failure. That protective film of oil will take your vehicles and weapons into battle and bring them back again.